All right, hello. Today we're learning about linear inequalities and problem solving. I know I've got this when I can define linear inequalities in one variable and graph solutions on a number line, solve linear inequalities, and applications. Key vocabulary: linear inequality, greater than, less than, solution of an inequality, solution set, set notation, and a graph of an inequality. So an inequality is not equal. You can pause this and write it down if you want. A solution of an inequality is a value of the variable that makes the inequality a true statement. The solution set of an inequality is the set of all solutions. So a solution is one that makes it a true statement, but the solution set is all solutions. So the inequality x is greater than 2 has a solution set of the set of all numbers such that x is greater than 2. And you can see how that's written, and that when they ask you to write it as a solution set, that's what they're wanting. So graph the following on a number line. So x is greater than or equal to 3. Remember, if you have a greater than or equal to or a less than or equal to, you're going to have a closed circle. And you have a greater than or a less than, you're going to have an open circle. Okay, so since it's or equal to, I did a closed circle. All right, B, we're doing together. X is less than -3. So you put an open circle at -3 and you go less than. Now, something people don't all the time notice is that the greater than sign and the greater than side of the number line match, and the less than matches the less than arrow. Okay, and then you're going to do letter C by yourself. So go ahead, try. And you should have gotten this because it is x is between 0.5 and 4. So you're going to have an open circle because it says 0.5 is less than x and x is less than or equal to 4. So you're going to have the shading in the middle. Okay, addition property of inequality, basically they're equivalent inequalities if you add the same thing on either side. So 2a, solve x plus 4 is less than 9, so I'm going to add 4 to both sides. And I'm going to get x is less than 13, and so to graph it, it would look like this. You would have an open circle at 13 and be pointing to the left. Okay. The multiplication property of inequality basically says that if you multiply or divide by a negative, you have to flip the sign. Okay, so make sure if you're multiplying or dividing by a negative with an inequality, you flip the sign. So, all right, -3x is less than or equal to -9. So if I divide both sides by -3, I would get x is greater than or equal to a +3. So my numbered line would look like that. Solve and graph the solution. So if I divide both sides by -2.6, I'm going to get x is greater than a -4. And my line, well, my line looks like that. So I'm starting at -4 with an open circle, and I'm going to the right. All right, you can pause this and you can pause this and read how to solve an inequality on one variable. All right, 2a. Continued, part D. All right, so solve 4x plus 5 is greater than 3x minus 7, and then graph. Okay, so I am going to combine like terms just like I would with an equation. So I've got 4x minus 3x is just 1x plus 5 is greater than or equal to -7. I'm going to subtract 5 from both sides, and I'm going to get x is greater than or equal to -12. And then you graph, and so it looks like that. You put a closed circle at -12 and graph to the right. Okay, 2B, we're going to do this one together. Okay, so we're solving it again, just like you do an equation. The only difference is if you multiply or divide by a negative, you flip it. All right, so I'm going to distribute. So 3x plus 9 is greater than or equal to 5x minus 5. Combine like terms, so I am going to subtract my 3x so that I have a positive variable. So I've got 9 is greater than or equal to 2x minus 5. I'm going to add the 5 to both sides of the equation. So I get 14 is greater than or equal to 2x. Divide by the 2, and I get 7 is greater than or equal to x. But in inequalities, we always want the variable to be on the left. So you flip the whole thing around and you get x is less than or equal to 7. That way, if you're graphing, you know which way to go to, because this matches this, so you go that way. Okay, you're going to do this one by yourself. Go ahead and pause it. You should have gotten x is greater than 2. Okay, so I'm going to do this one. So let's start distributing. So you've got 7x minus 14 plus x is greater than negative 4 times 5 is negative 20. Negative 4 times negative x is plus 4x minus 12. All right, so you combine like terms on either side of the inequality before you start moving everything. So 7x plus x is 8x minus 14 is greater than negative 20 minus 12 is negative 32 plus 4x. So I'm going to subtract my 4x from both sides to keep a positive variable. So that 4x minus 14 is greater than or equal to negative 32. Add 14 to both sides, and you get 4x is greater than negative 18. Divide both sides by a positive 4, and you get x is greater than negative 9 over 2. And you can see that is the answer. So how do we graph that? It's on a number line, so negative 9 over 2 is actually negative 4.5. That's why it's there with an open circle, and it's going to the right. All right, 3B, we're going to do this one together. So we're going to go ahead and distribute. So 3x plus 12 is greater than 3x plus 5. If I subtract the 3x from both sides, what happens? You get 12 is greater than 5, which is a true statement. So your answer would be all reals, or all real numbers, signified by a R with a line through it. So if you were going to graph this, it would actually be a solid line on the graph. So the whole line is shaded. Okay, 3C is 8 minus 3x minus 6. So let's distribute that negative. So we've got 8 minus 3x and minus a negative 6. So that'll be plus 6, because negative 1 times negative 6. And then negative 4x, negative 4 times 1 is negative 4. Now get your like terms together. So 8 plus 6 is 14, minus 3x is greater than negative 4x minus 8. Okay, so we're going to combine like terms. So I'm going to add the 4x to both sides to keep a positive variable. So you have 14 plus 1x is greater than or equal to negative 8. Subtract 14 on both sides, and you get x is greater than or equal to negative 22. Okay. 4. A salesperson earns $800 per month plus a commission of 25% of sales. Find the minimum amount of sales needed to receive a total income of at least $1,800 a month. So this is going to be the formula that we're going to use. This is our inequality. So she earns $800 per month plus a commission of 25% on the sales. So we don't know the whole question is find the minimum amount of sales needed to receive a total income of at least $1,800 a month. So $1,800 at least. So she could earn more than that, but she needs to at least earn that. So how do we solve this? We're going to subtract 800 from both sides. And I get 0.25x is greater than or equal to 1,000. So if I divide both sides by 0.25, I would get x is greater than or equal to 4,000. So the answer is she needs to sell at least $4,000 worth of, let's see, the minimum amount of sales needed for the salesperson to earn at least $1,800 a month is $4,000 a month. So she needs to sell $4,000 of merchandise to make at least $1,800 per month. Okay, let's do this one together. A salesperson earns $2,000 a month plus commission of 20% sales. Find the minimum amount of sales needed to receive a total of at least $6,000. Okay, so she earns $2,000 a month plus 20% commission on sales, and she wants to sell at least, so more than, greater than or equal to, $6,000. Okay. So we're going to subtract 2,000 from both sides. And I get 0.20x is greater than or equal to 4,000. If I divide by 0.20, that's the same thing as multiplying by 5 over 1, by the way. You get 20,000. So the answer is they need to sell at least $20,000 in sales to have an income of at least $6,000. Okay, so here's some extra practice. I'm going to go ahead and get you to pause the video and work these out, and I'll show you the answers in a second. After I show you the answers, you can pause it and check. And let me know if you have any questions. Okay, please let me know if you have any questions about that or if you're getting stuck on anything. So I know I've got this when I can define linear inequalities in one variable and graph solution sets on a number line, solve inequalities, and solve inequality applications. But do you really understand? Inequalities can be solved the same way as equations with one important difference. What is the difference? When multiplying or dividing both sides by an inequality by a negative number, the direction of inequality sign must be reversed or flipped. What are some examples of words that indicate that an application problem can be represented by an inequality? Greater than, less than, at least, at most, between, no more than, no less than. All right, I hope that this helps you understand. Have a great day.